Now I would like to take a look at a transformed sinusoidal equation. So I'm going to begin by subtracting 3 from both sides or adding -3 to both sides. That's the subtraction property of equality, as you all know. Then I'm going to divide both sides by 4 or multiply both sides by 1/2. Now, I know last year, because of the pandemic, some of you missed out on this. So there's a few ways to look at this. I like to think about trig conceptually. So what drives the unit circle? It's the first quadrant. So if I look at the first quadrant, and I'm not on the unit circle now, that means theta reference is pi over 6. In what quadrants is the sine ratio? Now, on the unit circle, the sine ratio, as we all know, is the y coordinate. So here we have our x and we have our 1/2. So where is it positive? It's positive in the first quadrant. It's positive in the second quadrant. We eliminate the third and the fourth. Now, in the first quadrant, that means the sine of x is 1/2. That means x is pi over 6, and by adding 2 pi n, I get all other coterminal angles with it. This is the general solution. If I restricted my domain to just 0 to 2 pi, then I only need that. In the second quadrant, if you want to think about that, you would put this here, and this would be pi minus pi over 6. However, you should recall that that's 5 pi over 6, and we add 2 pi n again. Why? To get all of its coterminal angles. By adding 2 pi n, where n is an integer, you can either rotate counterclockwise or clockwise. So n's positive and negative. If n is 0, again, there are the two solutions on 0 to 2 pi.